This lesson is on some ways to prove triangles congruent. This is section 4-2 in your textbook. The essential question for this lesson is, how can you use deductive reasoning to show that triangles are congruent? In the previous lesson, we talked about triangles being congruent, and we mentioned how a triangle is composed of 6 parts, 3 angles and 3 sides. And if they are congruent, then all corresponding parts, all 3 sides and all 3 angles, are going to be congruent as well. Well, it's not necessary to take and show that all 6 parts are congruent in order to show that the 2 triangles are congruent. There are some postulates that we're going to talk about in this section, which are facts that are accepted as true, that we do not have to prove, that will indicate whether or not you have congruent triangles. The first postulate is postulate 12, or as it is sometimes referred to as the Sss postulate. And this postulate simply states that if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. That's why this is referred to as the Sss postulate, because it only deals with the 3 sides, Sss. We don't care anything about the angles. If those 3 sides are congruent, then the triangles are congruent. The next postulate is postulate 13, and this is often referred to as the Sas postulate. Notice I still have 2 S's in it, which indicates sides, but I have an A, which probably indicates we're going to talk about angles. So this postulate states, if 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of another triangle, then the triangles are congruent. Now, the key here is to understand what it means by the included angle. It's the angle made up of those 2 sides. So if you've got 2 sides of one triangle, they're obviously going to be adjacent, but the angle that we're talking about has to be the angle between those 2 sides, okay? It cannot be an angle opposite one or the other of the sides that we're talking about, okay? So hopefully you'll understand that. It's the side, the angle, it's 2 sides and the angle between those 2 sides. It's the angle made up by those 2 sides. That's what we're talking about. And that's the reason it's Sas, why A is between the 2 S's. Now the last postulate we will talk about in this section is postulate 14. And this is referred to as the ASA postulate. Now, based on what we've already been talking about, the fact that it says ASA kind of would imply we're talking about 2 angles and a side. Now this postulate states, if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. Again, be careful with this word included. So we've got 2 angles of one triangle and 2 angles of another triangle. The side we're concerned about is the side between those 2 angles. It's the common side, if you will, for those 2 angles. So that's what we mean by the included side, okay? So if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. So here are a couple examples to show the difference between SAS and ASA. The one on the left is SAS, or side angle side. Notice that angle B and angle E are between the 2 sides, okay? Angle B is between side AB and BC, and angle E is between side DE and FE. So this is obviously SAS. Now the one on the right is ASA, angle side angle. And you'll notice the side that's congruent is between the 2 angles, okay? So this one on the right is angle side angle, the one on the left is side angle side. Now I would like you to go to page 124 of your textbook and do problems 4, 5, 6, 7, 8, and 9. These are the classroom exercises, and post your answers in the drop box.